We'll start our journey into hypersonic flows with an overview of what we mean when we say that something is moving at a hypersonic speed. A hypersonic speed implies that an object is travelling at a very high speed. A quick aside before we start. We're going to be thinking about objects moving at high speeds through gases and also flows at high speeds moving past stationary objects. So I want you to think about the speed of a flow relative to an object. This is an image of a hypersonic vehicle in one of our hypersonic wind tunnels at UQ. In a wind tunnel, we usually hold the object stationary and move the air around it. And that is what's happening in this experiment. Say you're on the ground on a calm day and you look up and see a jet aircraft flying past. We'll ignore any wind for now. You see the plane moving through stationary air at a high speed. Now imagine that you're in that aircraft. Now you feel like you're stationary and that the air is moving past you at high speed. It's the speed of the air relative to the aircraft that is important. So we can simulate the flow around an object in a wind tunnel by blowing air past a stationary model, just as we're doing in this experiment. So, back to our topic, hypersonics. The sonic part of hypersonic refers to the speed of sound. So a hypersonic speed implies an object is travelling at many times the speed of sound. You've probably heard of Mach number, named after the famous Austrian physicist Ernst Mach. The Mach number indicates how many times the speed of sound an object is moving. Therefore, the Mach number is the speed of the object divided by the speed of sound. So an object travelling at half the speed of sound would have a Mach number of 0.5, and an object travelling at twice the speed of sound would have a Mach number of 2. An object travelling at 10 times the speed of sound would have a Mach number of 10. We'll discuss the Mach number in much more detail in future units. But for now, it suffices to say that the Mach number is an important parameter that helps us to distinguish between different types of flow where different phenomena occur. When an object is travelling at a speed that is low relative to the speed of sound, the fluid ahead of the object can receive information that the object is approaching. This is an image that shows a low-speed flow travelling from left to right and passing around a cylinder shown in red. The blue lines indicate streamlines in the flow. All the fluid between consecutive streamlines stays between the lines as it passes around the object. So we see here that the flow knows that the cylinder is approaching and it deflects ahead of it to pass around it. Then, after the cylinder, it flows back towards the centre line. We talk about objects that travel at speeds less than the speed of sound as being travelling at subsonic speeds. And the flow shown here is a subsonic flow. Subsonic refers to Mach numbers from 0 to just under 1. If an object is travelling at a speed that's higher than the speed of sound, we say that it's travelling at a supersonic speed. So anything travelling at a Mach number higher than 1 is referred to as supersonic. This image shows the flow around a sharp cone in a gas moving at almost 4 times the speed of sound. There are some important differences between subsonic and supersonic flows. Some strange results occur when the flow speed is more than the speed of sound. And some of these seem counterintuitive from our experience with low-speed flows. Vince Wheatley will go into this in more detail in section 2 of the course. And it's in supersonic flows that we find shock waves. The dark line in this image is a visualisation of a shock wave. We'll look at those in this section soon, and we'll go into more detail about shock waves in section 3 of the course. But you'll have to wait for that. So we have subsonic and supersonic speeds. What about hypersonic? This image shows a visualisation of the flow around a hypersonic spaceplane in the T4 shock tunnel at UQ. I said that hypersonic speed implied that an object was travelling at many times the speed of sound. So you might be thinking, surely that means it's supersonic. If it's travelling at many times the speed of sound, then it's travelling at more than Mach 1, so it's supersonic. And you'd be right in thinking that. But you don't get any marks for that just yet. So what is the hype about hypersonics? Well, there are some important things that occur when the Mach number gets high. For one thing, the temperature can get very high. If the temperature gets high, then we start getting changes occurring in the chemistry of the gas. For air, we start dissociating the oxygen molecules into oxygen atoms, and at higher temperatures start dissociating the nitrogen molecules into nitrogen atoms. This takes some energy out of the gas and changes the properties of the gas. Richard Morgan will go into these and other effects that occur at hypersonic speeds in more detail in section 5 of the course. But again, you'll have to wait for that. So how fast does something have to be travelling before these sort of effects become important and we start calling the flow hypersonic? There's no distinct border between supersonic and hypersonic flows, but we usually set the demarcation at Mach 5 times the speed of sound. So anything travelling at faster than Mach 5 is referred to as travelling at a hypersonic speed. It is at around this Mach number that the character of the flow is different enough from that at lower supersonic speeds that we need to start to look at it differently. Before we finish this unit, there's one more region of the flow that I should mention, where things are also a little different. There's a regime of speeds that we call transonic. Transonic is not as precisely defined as subsonic and supersonic flows. When an object is travelling at close to the speed of sound, there are usually regions around the object where the flow is subsonic and regions where it's supersonic. This is the transonic regime, and it's usually taken to occur for Mach numbers between 0.8 and 1.2. This image shows the visualisation of the flow around an aircraft travelling at a speed just above the speed of sound, so Mach 1.1 in this case. This is in the transonic flow regime. Again, the dark lines are visualisation of shock waves in the flow. We won't be dealing much with transonic flows in this course. That'd be a course in itself. So we can summarise the flow regimes as follows. We look at the Mach number being defined as the speed of the object divided by the speed of sound. And we've got a line here taking us from Mach 0 up to Mach many. We say between Mach 0 and 1 that the flow is subsonic. Around that Mach 1 region, from maybe Mach 0.8 to 1.2, we call transonic, where there's regions of subsonic and regions of supersonic flow. Anything above Mach 1 we refer to as supersonic, and that region above Mach 5 of supersonic flows we call hypersonic. In the next unit, we'll look at the speeds at which different sorts of ground, air and space vehicles travel. This will give us a feel for how fast objects are travelling when they're in these different sonic regimes.